Hey guys, a very good day to you all. So in this video, we will understand what is Nernst equation. So before understanding this topic, I want to make clear that you must know what is cell potential and what is electrode potential. If you don't know what is cell potential and electrode potential, you can find the link in the description box. Okay, and then you can watch this video. So let's start with this topic, that is Nernst equation. So Nernst told us that cell potential and electrode potential depends on three factors, that is temperature, concentration of the solute, that is the electrolytic solution, and pressure of the gas. Okay, now on the basis of this he gave us a equation which is E is nothing but equals to E naught minus RT upon NF into log to the base E products upon reactants. Don't worry, I will explain you all each term individually. Just keep patience. Okay. Now since it is log to the base E, and for our calculation we want log to the base 10. So if you want to convert this log to the base E to log to the base 10, you have to multiply by 2.303. So this equation now becomes E is nothing but equals to E naught minus 2.303 into RT upon NF into log to the base 10 products upon reactants. Okay, now what is E? E is nothing but your cell potential or electrode potential. And what is E naught? E naught is nothing but standard cell potential or standard electrode potential. So if you want to calculate cell potential, then your E naught will be standard cell potential, and if you want to calculate this E to be electrode potential, then your this E naught will be standard electrode potential. So it depends on you have to calculate cell potential or electrode potential. Now further on moving at 25 degrees, so I forgot to mention these terms. This R is nothing but your gas constant, and this value of gas constant is nothing but equals to 8.314 joules K inverse mole inverse, and these products and reactants is nothing but your concentration of products upon concentration of reactants present in the electrolytic solution. As we all know, in the galvanic cell there is a oxidation taking place and reduction taking place. So after oxidation and reduction there are certain products formed. So this products is nothing but the concentration of those products over here upon the concentration of reactants, and your this T is nothing but temperature in kelvins, not in Celsius, but it will be in kelvins, and this N is nothing but moles of electricity passed, number of moles of electricity passed. As we all know that electricity in a galvanic cell moves from anode to cathode, that is, so electrons move from anode to cathode, therefore the number of moles of electricity passed is that N over here. Okay, and your F is nothing but equals to Faraday's constant. Now if you don't know what is this Faraday's constant, again I have made a video on this. You can find the link of this Faraday's constant video in the description box. Okay, and the value of this Faraday's constant is nothing but equals to 96500 coulombs per mole of electrons. Okay, now I will substitute the value of temperature as 25 degrees Celsius. Okay, so just substituting the value of temperature to be equals to 25 degrees Celsius, which means 25 degrees Celsius means if you want to convert in kelvins, we have to add 273 plus 25. Okay, which is nothing but equals to 298 kelvins. So now I will substitute this value of 298 kelvins over here. Okay, now therefore this equation becomes E is nothing but equals to E naught minus 2.303 into what is the value of R, which we know, 8.314. Substituting this value now, 8.314 into T what we have taken, 298 kelvins, into 298 kelvins, and we will substitute the value of this Faraday, which is nothing but equals to 9600 and 500, and we will keep this N as it is. We won't be substituting this N into 965,000 into this log to the concentration of products upon concentration of reactants. Okay, now if we simplify this calculation, we will get as E is equals to E naught minus 0.0592 upon N into log to the base 10 concentration of products upon concentration of reactants. Now why have we done this simplification? We have done this simplification because in many a times in the exam you will find the value of temperature to be 25 degrees Celsius, that is the standard temperature. So in order to avoid the wastage of time solving this whole thing in the exam, it is easier to remember this short formula, because almost 90% of times in the exam when the sums comes on this type, you will always get temperature as 25 degrees Celsius. Now again considering this equation, this is our main equation, right? Now you want your cell potential to be equals to your standard cell potential. So we have done in the previous video. What is standard cell potential? Standard cell potential is nothing but when the concentration of these ions is 1 molar and the temperature is 25 degrees Celsius, and your this R remains as it is, and this number of moles will be equals to 1 again, and log to the base 10 of 1, the concentration of products is 1 molar and reactants is also 1 molar. So therefore our this will now become E is nothing but equals to E naught minus 0.0592 upon N into log to the base 10 of 1, because 1 upon 1 is ultimately going to give you 1 only. Now again simplifying this, log value of log to the base 10 1 is 0. So therefore if you multiply this whole thing with log to the base 10 of 1, you will always get what? 0. Okay, therefore E will now become equals to E naught. So guys, thanks for watching this video. If you have liked this video, then please to subscribe to the channel. Do share this video with your friends, and please do not forget to subscribe to the channel. And guys, thanks for watching this video. Do comment below and do comment the video which you want in chemistry, guys. Thanks for watching this video.